Christmas feels already far, far away, but before Christmas we went through the curve tools as an introduction. But what I haven't actually gone through was the Grasshopper portion of the curves, which I will do in this video. I will not go through all aspects of curves within Grasshopper, but just give you an introduction of some of the aspects. So we open Grasshopper by either typing Grasshopper or by pressing this button here, Launch Grasshopper. Normally, if you open it, it would be like this. So it would be here on the parameters section. We went briefly through how to construct a point and how to deconstruct a point. And now we go into the next one, which is curves. Also in the parameters, there are these geometry containers, as they are called. For example, here we have point container, circle container, and we have a curve container. There are different containers, and what it means, they can make curves which are, for example, inside 3D world in Rhino, can be made available within Grasshopper. And how to do that is I draw a very simple curve, and if I select it and I go back to Grasshopper. By the way, if Grasshopper is disappeared like this, it's still running. You just type in Grasshopper and just go back. So now I've selected this curve and I got my curve container. And now if I right click, then I can set a curve or multiple curves if I have more curves than one curve. And now this curve is stored in here. So I basically made it available within Grasshopper to do next steps with it. Now if we go from the parameters tab to the curve tab, we see this 1, 2, 3, 4, 5 different sections. And we haven't really talked about analysis or division. We mainly generated curves at the moment, which is the equivalent here, primitives. We can find some of the things we already did before. For that reason, I might just open this again because that was quite useful. But still, maybe just to give you a quick overview, in analysis you can get a lot of information out of your curve. For example, you can get, and if you click on this down button or just on the black bar, you see that there are many more tools in here. But just to show you what's possible in here is, for example, you want to get the control points of a curve. Now you could say, yeah, I have my control points here, but what you actually get in Grasshopper are a list of coordinates. For example, you can get the coordinates of these points, which could be extremely useful if you want to use these points in a way. And I'm just demonstrate you something you don't have to follow, but just for you to better understand on how powerful Grasshopper is. If you want to do certain things, or it would be tedious to repeat over and over again within Rhino itself. For example, I want to extract these points, which I just did. And then I want to draw vertical lines on these points. I want to keep them on these points, meaning if I change my curve within Rhino, these lines update as well. So how to do that? I take my line tool. We saw that before, I think. And the line is defined by a start point and an end point. And I can say, these are my start points. And to make a vertical line, I just copy these points and move them in the set direction. And to move, I just use a command here. If you double click, you just go in here. MO move is already here. And now this asks me for geometry to move. So I can take these points, these are geometry, and move them. if I hover over this, you can see that there are already coordinates in it, and it translates the position, the current position of the point. It moves the points vertically by 10. Of course, you can put another vector in here. In order to make that more useful, let's we can go in here and say vector set in the set direction. Put this in here, and I just input a slider, and you can get the slider in a different way. You can actually just write here 100, and it gives you a slider with 100. This is very handy as well. So let's go on 32, and you can see that it moved the points by 32 millimeter. And I can change it here, and now I can just take my new curves, these are my endpoints, and plug them here. And now if I change, for example, the start point of the curve, then my geometry, which I created here in Grasshopper, will also update. I can do the same here. Let's turn this thing off. The grid is a bit annoying. And let's make this a bit more comfortable for the eyes. Okay. Even if I don't show it, and I change now my curve along the interpolation points, then it still updates my generated geometry. So as a next step, I mean, this is just playing around, but you never know where playing around leads you to. Sometimes you get really cool ideas. So this is analysis. There's way more things in there, of course. There is, for example, endpoint, start points, if I want to get the endpoint or start point. The curve middle point, for example, could be interesting. You can check if a curve is closed or not, and it will tell you either yes or no. So for example, I can put this here, and now I take my curve and plug it in here, and now it actually tells me the curve is not closed. So if you have a lot of curves in your model and you plug them in here, then you can weed out curves which are closed or curves which are not closed. And let's demonstrate it very quickly. So I have, and now I can actually set multiple curves. Wait, I need to let's select all these. And go here to select multiple curves. Now you're shocked. So it also uses this portion of the script to create all these vertical points, all these vertical lines. If I don't want to see that at the moment, because I'm actually looking at open and closed curves, then I can go here and right click and say close preview, and now this is closed. I can then partially open, for example, only the vertical lines if I want. But yeah, I was interested in open and closed curves. So now I get a list of false, true, false, true, false. Means these represents the different curves which are either open or closed. Just for you to better understand what could be the next step, I could now sort these curves into either closed or open curves, and then do something again with it. How to do that? You can go into sets and here in lists, because these are all lists, right? It's a list of either true and false, and this is a list of curves, and this is a list of points. So sets actually can manipulate these lists, and in here you can go to dispatch, and so you have this list of false, true, false, true. The input here in this dispatch tool, which sorts out, so it basically sorts out a list, which is a list of curves. So I can put this in here into a dispatch pattern, and you can already see true and false as a default value. Now I can use this list, this pattern of false, true, false, true, false, with, I can replace with the default in here by just adding it here. And now I get a list with closed curves and open curves. In a way, you could then stop the preview here, stop the preview here, and here as well. And now I could, for example, only use my script, which I did here, on either the open or closed curves. So basically we sorted this list of curves into open and closed curves, which are here. So either A or B. And now we just replace the input. Now we can see it because we turned it off. So we can turn this on. And now you see it only uses the script on the closed curves. And you could do the same with the open curves. So this is something you would need quite a while to do in Rhino. And especially then when you then add another curve, or you have a set with, I don't know, 5,000 curves. So what else do we have? I mean, there's a lot to analyze. So you can get the length of the curve, that gives you a number. There is one tool which I really love to use a lot, is the evaluate curve, that basically evaluates the curve at a specific point. Just to show you that quickly what that does. To evaluate curve, you just place here, you just connect it here with the evaluation tool. The parameter here, so what it does, it actually, maybe it's easy just to see it, you know. So if I add a slider here, you can see that it basically placed a point here. This is my evaluation point, and if I move the slider, it actually see that the point was moving just the length 1 along the curve. Now what you could do, so there are two ways to fix that. If I want to move along the entire curve, what it does, you can move along the curve, and it gives you again the location of the point. It gives you the vector, the tangent, and the angle. So you can then use all this information for any other script you might want to create. But now the problem is it just only moves until 1. Of course I could change my slider to 1,000 and just use the number here. But then I'm running into the problem that my curve is actually not as long, so it stops somewhere here. Assumed that it's continuous. So how to fix that? One way would be to just measure the length of the curve, so we can actually measure the length here in curve length. And yeah, we could then restrict my slider to that number. Let's say, okay, I have this number here. I can open it like this and then type . But that's a bit tedious, right? Especially if I have not just one curve, but I have several curves. But yeah, I could, and now because I choose integers instead of float point numbers, it actually reduced it to this. But anyway, so if I Now restrict it to this. It doesn't work, right? So there is something wrong. Okay, it's funny, now it works. Anyway, so I could measure my length, the length of my curve, and then restrict my slider, but it's not very useful, because what if I have several curves and I want to find the center or the middle point of that curve, for example. Then I need to divide that number by 2 and then put it in here, but then I have another curve which is longer. So let's do this. Let's say my middle point is somewhere here for this curve, but then it doesn't fit for the others. So there's another way to do that. It's actually by using, if you right click here on the curve symbol on this curve container, on the output, then and you go down, you can actually do something with the list. And one thing you can do here is reparameterize. And what this does, it translates the length of each curve to 1. So for example, this is 190 and this is 210 and this is I don't know, 120. Then it will output for each curve translated to 1. The length is 1. And that's why I can actually use here just 1 as a maximum. And if I go here to 0.5, then it gives me the center point of the middle point of these curves. Or I want to go to the quarter. Opla. Then actually get these points here. And they are always in the quarter of that specific curve. And then you can join these curves if you want with another curve. These points with another curve. For example, you can create curves either with the control points or interpolated. So we saw that before in the curve tool. We have the either control point curves or the interpolated curves, which is both just a method. So let's go for the interpolated one. So take this here, and now I just need to place my points, and it created a curve. Now if I move this one, it of course updates my curve here, and of course also in any direction. Yeah, so yeah, of course you can move this along the curves, and yeah, so you can, I hope you already see how powerful that can be. And now, although there's a lot of other stuff to cover, we'll not do that now. We'll do it for sure at some point. But I just want to go very quickly through some of the others here. For example, division. So there are all kinds of division tools in here. One is divide curve by number, one is by distance between the points, and one is by length between the curve, between the points. That's important to understand that there's a difference. But let's try just one of these, which is the normal, the easiest one is by the number of segments. Then we just go in here, we just take the curve, and that's it. So we could now, instead of having just one of these curves, we could actually have a curve along of each of these points. But it needs a third step in between, because at the moment, what it does, it actually creates points. It actually creates a curve, an interpolated curve between the points on each of these curves. So meaning that I have three lists, and so I have three curves, and they create three different lists of points. This is the first list, second list, third list. And you can see here actually it created that new curve. In order to draw curves like this, so basically from the first point to the first point to the first point, we kind of need to flip the list. Actually it goes from this side, I guess. So it starts here, first point, first point, first point, second point, second point, second point, and so on. We need to flip what's in the list, so I can control the amount of segments. I create two segments for each list, for each curve, just to get a better understanding here. So I have three curves to start with. I divide these curves in two segments. So that gives me three lists of points, right? So of coordinates, basically. Start point, middle point, end point. And then we have another list which is start point, middle point, end point, and so on. And another, and the third list with start point, middle point, end point. Now, in order to draw something like this, to connect these points, I need to flip the lists. So the first points create a list. So basically these 3 points create a list, and then these 3 points create a list, and then these points create a list. And there's a very simple tool, it's called Flip Matrix. And with this tool you can do exactly that. We created a framework for a surface. And of course we create more divisions here. And we could have more curves as well. So I mean, we're not bound to 3 curves. Let's remove this one. So I have 4 curves, for example. No, that didn't like that. By the way, I'm here in Arctic mode. Maybe I should go into, yeah, that's better, so we can see better what's going on. So the order of the curves are now a bit messed up, and let's flip that. Yeah, that did the trick. So you have to always check on how you select the order of the curves, of course. And you could of course restrict your slider to at least 2 segments, or at least 1 segment, 2 maybe better, so it doesn't create an error. If I go lower, if I go 0 here, then of course it creates an error. One, okay, yeah, fine, but that makes it more interesting. That's what you can do with curve divisions, and there's more, of course. So this could be, I never used this divide by distance. That could be really interesting. We haven't talked about the horizontal frames or perpendicular frames. That's something we can have a look in another video. Primitives, we already touched a bit on that, meaning that's where you create stuff. For example, here, a circle. You could create a circle on all of these points. It's a bit of an idiotic task, but let's do it. So you could actually create on all of these points a circle, and then give it a radius. What else? We also checked this here. We did the interpolation with this tool. Of course, you can play around with all of these things. Don't be afraid of doing something wrong. You can't do anything wrong. If your computer crashes, or if Grasshopper crashes, or Rhino crashes, just restart and try something else. Okay, I think that's enough for this video. Yeah, wait, one more thing we could do is actually creating a surface out of this. So let's lower the number here, and we could just bake these. So if you want to have these curves permanent in Rhino, then you can just bake them. Right click and bake, and it asks you in which layer you want to put it. Let's put it in default, and we can close it. Grasshopper is still open, by the way. Grasshopper is still open, and you can always, of course, turn it off. There's also a way to turn it off like this, so you don't see what Grasshopper is doing if you don't want to close the window. And now we can actually create a patch, or in that case, even better, surface from network curves. That's actually the best here. And yeah. Okay, let me know if you have any question. I'm happy to help you, as long as it has something to do with what I'm telling you here in these videos. Okay, see you next time.